Okay, so we're back in our MXD, and I've downloaded this USGS TIFF file, which is a digital elevation model, from the National Map Viewer. And I saved it in my lab folder, and now I'm going to bring it in to my MXD. It gives me a geographic coordinate system warning. Now, if you recall, we set our data frame to be WGS84, and this is in NAD83. So it's telling me that I have a geographic transformation warning because they're two different datums. If you want to convert from at NAD83 to WGS84, you can just click OK and close. Anyway, it projects the DEM on the fly. Now, this is what a 1 arc-second area looks like. If I go to zoom to layer, it has downloaded a digital elevation model for 1 arc-second area, even though this is a 1/3 arc-second DEM. So an additional benefit of having derived or drawn an AOI is that we are going to use this AOI to essentially clip our DEM to that specific area of interest by setting this as our mask area when we project this grid. Now, why do we have to project this grid? First of all, the good GIS etiquette is also going into your properties and looking at your data. So if I go to right-click on the DEM and I click Source, it tells me that there's over 10,000 by 10,000. There's a lot of grid cells in here. And when I look at the cell size, which tells me the resolution of the grid cells, it's in a weird units. It's into the -05. So that tells me there's something weird with this grid. And what it is that the grid is in global coordinate systems. It's not projected, so it's spherical. So those cell sizes are in decimal degrees. What we really need to do before we can work with this DEM in any kind of analysis is that we want to project the grid to a coordinate system that's planar, not spherical. So we need to select a projected coordinate system. Now, if you had looked and delved a little bit more deeply into the metadata for this particular data set on their website, you would have learned that the DEM, the Z units or the elevation units, are in meters. So each of the values in this DEM that go from 0 to 2,443, these are in meters. So we want to project this grid to something that where the horizontal units are in meters. You could project it into something that's in feet, but if you wanted to select slope or do any kind of terrain analysis, you'd also have to convert the Z values to feet. So we're going to pick a horizontal coordinate system that's in meters. So I'm going to have you project this DEM to a UTM Zone 11 North coordinate system, which is a projected coordinate system where the horizontal values are in meters. So to do that, we want to go to I'm clicked my toolbox, and I want to go to projections and transformations. You should already be very familiar with how to project something, but this time we're going to find it a little bit different. So we're going to go to data management tools, projections and transformations, and here we have a separate toolbox just for rasters, and this is where you want to be. So you want to select raster, and then you want to project this raster. So you want to select project raster. So we're going to open up this toolbox. And the input raster is going to be the GeoTiff. And I'm going to save it as Malibu or Malibu DEM. So I want to make sure I give it a meaningful name and a meaningful location. And I'm going to navigate to my DEM lab folder, and I'm going to call it, I believe in the lab I just called it Malibu. You can call it Malibu DEM, something like that. You want to have a short name. And this is where we want to set our input coordinate system. So I'm going to click on the hand. And I already have WGS84 UTM Zone 11 North in here, but if you don't have that in there, click on Projected Coordinate Systems, scroll to UTM, scroll to WGS84, select Northern Hemisphere, and find Zone 11 North. You could also do WGS83, whatever you wanted, but I'm going to have you do WGS84 UTM Zone 11 North. Now it says transformation optional. It's not optional because you have one that's in NAD83 and one that's in WGS84. So because you're doing a datum transformation, you also have to do this. You have to do this geographic transformation. And in the lab, I suggested to pull down this menu and pick the transformation file that's specific to California, Southern California. And when that comes in, you have to remove the original one. So you highlight the one that it picked as default and select X. So now it's going to use this transformation, and it's going to take the original grid, which is in spherical but NAD83, and project it to WGS84 UTM Zone 11 North. Everything else is okay, but before you push that button, this is the most important point of this step. We want to click on this environments box right here. So I click on environments, and this is where I'm going to set, if I go to my raster analysis settings, I want to set the mask to be the Malibu AOI. And I want to set my processing extent to be the Malibu AOI so that I have it set to my area of interest. When you do this on your own, you're going to set it to your own AOI. So that this will effectively do is when we see what happens, it's only going to focus on this area and produce a DEM specific to this area. So I'm going to click OK and project my DEM. When it's done, it adds the Malibu DEM to your table of contents. And if I turn off the TIFF, you'll see now that I have a DEM of beautifully preserving the extent of just my area of interest. This is also a big DEM. If I right click now on this DEM that I've just created and go to its properties, it has 3,000 columns by almost 4,000 columns by 1376 rows. And here my cell size is something closer to what I would have expected because this is a 1/3 arc-second DEM. That means it's an approximately 10 by 10 meter resolution. We projected it to UTM Zone 11, which means its horizontal units are in meters, and that means the units of the cell size are in meters. So each cell is 3.4842 by 3.4842 in distance. So it's a 3.4842 meter resolution DEM. So now you have your area of interest, a DEM for your area of interest, and we are good to go to the next steps in the lab.